Hey physics class, welcome back. We got momentum and impulse number 2. So video 2, we're going to go through questions 8 and 10 from practice sheet kind of number 1, or just the one that says practice sheet, and then we're going to go through question 6 from the practice number 2 sheet. Okay, and so some kind of different questions just to look at and kind of see how we can try to format these, look at them, and go over them. All right, so let's actually pull this up here. All right, that's what I want. Here we go. Question 8. It says, 1 kilogram ball. Did I want to do 8? Yeah, it says I did. All right, sounds good. It says an 1 kilogram ball hits the floor with a velocity of 2 meters per second, and then it bounces back up with a velocity of 1.6. What is the ball's change in momentum? Okay, so let's talk about change in momentum. This is the big reason why we kind of have to have direction in there, and so I'm going to draw this out. Okay, so basically if I draw a vector, because this is a vector actual thing, it goes down with 2 meters per second. So the momentum going down, I won't put that there yet, momentum equals 1 times 2. So it has momentum of 2 kilogram meters per second going down. That is important. When it hits the ground and comes back up, it has a velocity of 1.6. Okay, which means its momentum is 1 times 1.6. So it has a 1.6 meters per second. But that is going up. Okay, so many students want to just say that the change of momentum is 0.4. Okay, and that would be incorrect because it's actually changing directions. Okay, I think if in earlier the year we talked about basically like a change in velocity, if I'm going like this way at 2 meters per second, and then I slow down to 1.6, that would be a change of 0.4. But if I'm going this way at a speed of 2 meters per second, and then change directions, I had to get all the way to 0, and then speed back up going the other direction. Okay, so basically if we think of going down as positive, going up as negative, I went from 2 to negative 1.6. My change in momentum is 3.6. Okay, so that is my change in momentum. It's 3.6. Okay, kilogram per meters per second. All right, so that is our change. Anytime you actually change direction, that is going to be a big thing. Okay, in the sense of basically, if I think of like north being positive, east being positive, west being negative, south being negative, just like we went back to our dynamics and our vectors. Anytime we change direction, one of them has to be negative. So usually we say that going down is kind of negative. Actually, honestly, usually we say going down is negative, going up is positive. I had it different here, but nonetheless, you'll still get a change of 3.6 like for our momentum. Okay, so that's how to kind of look at A. Direction is very key. For B, okay, I'm just going to get rid of this. I'm going to keep that change right there. For B, if the ball is in contact with the floor for 0.06 seconds, what average force is done to exactly earn the ball? So that's where we're going to look at our impulse. Our change in momentum is our impulse. So our impulse is 3.6. All right? And if I have a formula of force multiplied by time, I have the time here. Time, 0.06. And so I can figure out pretty nicely impulse over time gives me my force, which is going to equal, where is that answer? There we go, 60 newtons. Okay, 60 newtons. Now, that is the force of just the change of momentum. Okay, I'm going to get an object here. I don't have a good one, but we're going to use some post notes. So, if this were to be going down and then back up, that's the change in momentum. Okay, it says what is the average force? This is a tough one for students sometimes is because they just want to find that one force. The thing is there's always going to still be like a force of gravity. A force of gravity is still going to be on this thing as well. So to find like my total like net force in this one is going to be like force of like the change in momentum, okay, or like the impulse plus my force of gravity. Okay, because if I just hold this here, if I hold this here, what is the average force on this? Well, it's the 1 times 9.8, so 9.8 gravity. If I am now changing the momentum, I have to exert more force on top of that. So it's going to be my 60 times force of gravity. So force of gravity in this instance, 1 mass times 9.8, so 9.8. So my actual full net force is 69.8 newtons. This last part where that force of gravity always gets students, it's kind of a tricky last part, okay? All right, hopefully that question is pretty good. Let's keep going. I think the next two are honestly easier than this one. Let's look at question 10. Question 10, a physics dragster, okay? I'm going to underline this with as much emphasis as possible. It's traveling at 35 kilometers per hour east. Please change that right away to meters per second. Divide 3.6, get my meters per second. When I divide that by 3.6, I get 9.7 meters per second, okay? When it hits the gas and accelerates at 12.5 meters per second squared for time of 3.25, okay, seconds. What is the change in momentum? What is the change in momentum? Now there's a couple different ways that we can kind of look at this one. We need the change in momentum. We basically need the impulse, okay, which we can think of as either a force multiplied by time, if you want to think of it, or we can just think of like what's the change of my momentum and velocity, okay? And I'm going to think about it kind of for here. You do have a time here, and so if you want to try and figure out like what's the force needed to actually have this, you can try and figure out force equals mass times acceleration. Because you have the acceleration and you have a mass, it doesn't give any gravity in there, so we could possibly kind of work this out. We'll maybe take that strand and see if it works as well. But let's go with my surefire one right now, which is what's my velocity change, and then we can go through this. Okay, so let's go through our actual thing here, our change of momentum. I can figure out what my new velocity or my velocity change is. If I want to find my change in momentum, it's going to be equal to the change in mass times the change of velocity. Now the nice thing is my change of mass is not happening here, so I can kind of just ignore, like I can just have the same answer here. So I just need to find what the change in velocity is. What is the change in velocity actually going to happen here? So if I take my first formula for kinematics, okay, acceleration equals velocity final minus velocity initial over time, I can figure out my VF, okay? And then I can minus it from that right there. So let's do that, okay? I have VI of 9.7, I have a time of 3.25, and I have an acceleration of 12.5. So if I put that all in, okay, so 12.5 times 3.25, and then plus 9.7, I get a velocity final of 50.3. Now I don't want to use that. I want to use what's my change in momentum, what's my change in the velocity. So I'm going to take this minus this. Minus 9.7. And so my change in velocity equals 40.6. All right, nicely now I can just take that, multiply by my mass, and I will get my change in momentum. So I'm going to take that 40.6 times 1200, and I get 48,720. Okay, so there is the change in momentum, 8 kilograms, meters per second, and I think it was still going east. There's my full answer there. If I were to go this way, mass times acceleration, again, it's not going to give me the same thing here because basically I have a mass. I'm trying to multiply it by just my acceleration. That's my force, and I could possibly multiply my time if I were to take this. Okay, so I would take 1200 times 12.5 and times it by 3.25. I would also get, so if I do this, mass 1200 times acceleration, 3.25. Okay, I get, oh, my bad, not 3.25, 12.5. My bad. 1,200 times 12.5. Okay, I get 15,000. And if I times it by my time, like now that I have my force, I can multiply by time, 3.25. I also get 48,720. So you see that I can, one second. I can get my answer kind of both ways, looking at either the change of momentum with my velocity, or if I figure out the force and kind of use my dynamics way, I can figure out, but they both give me the same answer. Okay, so two ways to kind of look at this question here. All right, last question. This is from practice sheet number 2, number 6. And it looks like this. This one's a very similar one to the last one in the sense of what is the change of momentum in a 50 kilogram, that goes from 5 to 11 meters per second. If this change happened in 3 seconds, what is the average force? Okay, so I'm actually looking for that average force. So I need to find the impulse first. I know that it's going to change by 6. So what's my change in velocity? So my change in momentum equals mass times change in velocity. So my change in momentum is going to be 50 times 6, because that was my change. If you wanted to find the before and after, and then minus the two momentums, you'll get the same answer. Basically, my change in momentum equals 300 kilograms meters per second. Just looking to make sure I got that right on mine. I'm 99% sure I did. Okay, cool. And then if I want to get my actual force, that change in momentum is my impulse. So 300 equals force multiplied by 3. That's how much time I have. Divide by 3. Divide by 3. Force equals 100 newtons. Okay, so that's how much force they were using to speed up here. All right, so there's those kind of 3 questions looking at now manipulating all like the actual momentum with these as well. And then kind of looking at as well as like how does kinematics work in here? How does dynamics go in here? And then I think next question we'll even have one kind of around energy. Okay, how am I going to work energy into these possible questions? All right, class. Thanks so much. We have one more video for our momentum. That'll be it. Thanks.